Hi guys, it's Mrs. B. Welcome to the first lesson of our online algebra class. So to start, you are going to go to the newest, or you can go down to classwork, and you'll see Unit 7, which we are in right now, and you click on it. Let me go back. And you click on Lesson 1, Linear Regression. Okay, you can also see the date, March 19th. You're going to be doing this lesson Friday, March 20th. You go over to instructions, and you'll see the instructions. Okay, so it says, please watch the video and hand in the assignment. Okay, if you look at the attachments on the bottom, number 1 says linear regression. Okay, that's the blank PowerPoint. If you would like to open that, okay, you can press the little arrow on the top there. And it opens it for you. Okay, you can either make a copy of that for yourself and print it out and take notes. You can take notes right on your iPad, or you can take notes in a notebook if you want. You don't have to print any of these things out if you don't have a printer. Okay, that's totally up to you, but I would advise that you take notes. So I'm going to go back to our classroom. And if you look at the other attachments on the bottom, okay, linear regression and correlation coefficient in GeoGebra, functions chart, and linear regression A1. Okay, all of those things you're going to be opening at some point. Okay, so let's start the lesson. And throughout the lesson, I'm going to be opening up the linear regression and correlation coefficient in GeoGebra page and the functions chart. Okay, so you're going to need both of those things if you want to open them up on your iPad as well. So I'm going to take you to the lesson now. We're going to begin. So, we have done this lesson already. We've talked about linear regression, but I don't think we had a good understanding of how to do this in our calculator. Okay, so today we're going to talk about both linear regression, what it is, and what a correlation coefficient is. Okay, so by the end of this lesson, you should be able to use your calculator to find the equation of a line when given data represented in a table. And you should also be able to find the correlation coefficient and determine its strength. So, first off, okay, the formula or the equation for linear regression, okay, we're going to say f of x equals mx plus b. Hey, we've seen this before, haven't we? Okay, y equals mx plus b. Remember, f of x just represents y. Okay, so really, this is just the equation of a straight line. Remember, linear means straight line. So all we're doing today is talking about straight lines. Okay, if you look at the two charts on the bottom, okay, we have two charts of almost straight lines. Now, the reason we're talking about regression today and correlation coefficients is because we're actually going to be using data points, which if you look, all these little blue dots, now they're turning green because I'm clicking on them, okay, they're all data points. And what a linear regression and a correlation coefficient do is it takes a line, it makes a line for you that is the average of all these little blue dots. Okay, if all those blue dots were a line, it would create a straight line, such as the ones that you see in the pictures. Okay, so these are both linear lines. So what is a correlation coefficient? Okay, a correlation, okay, is a graph used to determine whether there is a relationship between paired data. Okay, a scatter plot can tell us if there is a strong or weak correlation between two sets of data, and if that correlation is positive or if it's negative. So if I look at the charts on the bottom, all correlation really does, the correlation coefficient, what it really is it's a number. So the correlation coefficient is just a number. that's going to tell us, okay, whether it's strong or weak and whether it's positive or negative. So if we look at the chart at the bottom and we see all these different tables with little blue dots, okay, a correlation coefficient is always going to be somewhere between 1 and -1. So you could see a correlation coefficient like 0.98 or 0.75 or 0.12. The closer you get to 0, okay, in the positive direction or in the negative direction, the weaker it gets. So if we look, we have a perfect positive correlation here. Okay, these are all correlation coefficients. Okay, we go to the second one, and it's still kind of a strong positive correlation because the dots are very close together. And the reason it's positive is because, remember, when the graph goes in this direction, it's a positive direction, as opposed to the opposite end here, a negative direction. Okay? And as we go closer to 0, the dots are starting to spread out. So we call it a weak positive correlation. It's still kind of going in the positive direction, but it's kind of weak. And 0, if you have a correlation of 0, it means there's no relationship with these dots whatsoever. They're so sporadic that we can't even make a line to represent, a straight line that represents those dots effectively. Okay? And then we can go the opposite way. All right? We could have something like negative 0.12. Weak negative correlation, where we can kind of draw a line going in the negative direction, but it's still not great. A strong negative correlation. We're getting better, right? The dots are getting closer together, and that could be something like negative 0.75. And then we get a strong correlation here, a strong negative correlation, because the dots are almost in a straight line on their own. And that would be a number that's really close to -1, like negative 0.99 or negative 0.98. Okay, the closer we get to -1, the more perfect of a correlation we have. So this is what we call correlation coefficient. Now, how do we find correlation coefficient? The good news is that you don't need to do it on your own. The calculator, GeoGebra, will do everything for you. So, let's take a look at some of these graphs, because on the regions, it will ask for you to determine whether it's a strong or weak relationship, and whether it's positive or negative. Okay, so it says for each of the following graphs, state whether there is a strong positive, strong negative, weak positive, weak negative, or no correlation. So what we're trying to guess here, or what we're trying to determine, is we either have strong versus weak, and we also have positive versus negative. And in a rare case, we could have no correlation whatsoever. So if we look at these things, let's look at the first graph right here. Okay? And the first graph, when I look at this, we can kind of tell that, well, the dots are really spread out. So I would definitely call that a weak correlation. But they are kind of increasing in a positive direction. Okay? So I would call this a positive, or a weak positive correlation. You don't have to write out positive or negative. I'll cut you some slack. Okay, when I look at the second one, the dots are closer together. So I would call this a strong. Okay, now we have to figure out positive or negative. Well, it's going in the negative direction. It's going down, so that's negative. Negative correlation, strong negative correlation. The third one here. Okay, when I look, dots are so spread out, I'm going to call it weak. Okay, if the dots are really spread out like that, it's pretty weak. But we could still see some sort of pattern that they are decreasing, right? From where we start to where we end up. So that's a negative line. The one on the bottom here, I can't really tell which direction I would even begin to draw that line in. Their dots are so spread out. So I'm going to call that one no correlation whatsoever. And the last one, okay? The dots are pretty close together. I'm going to say that's strong. And we're going to call it positive because it's going in a positive direction. The arrow is going in a positive direction. Again, if this is too fast for you, you can always pause the video. You can replay the video. Just make sure you're taking some sort of notes, whether it's on your own slide or whether it's in your notebooks. So, let's look at some examples here, okay? Emma recently purchased a new car. She decided to keep track of how many gallons of gas she used on 5 of her business trips. So here's all 5 of her business trips in the table. 1, 2, 3, 4, 5. The results are shown in the table. Write the linear regression equation for these data points. Round to the nearest hundredth. So remember, when we talk about the linear regression equation or the formula, okay, we're talking about f of x equals mx plus b. Okay, the equation for a straight line. So I'm immediately, the first thing I'm going to do when I see linear regression equation is I'm going to write that down. Okay, f of x equals, mistake, mx plus b. Now remember, m represents our slope, b represents our y-intercept. Okay, and I'll even go back and I'll add that in here. Okay, m is the slope, b is your y-intercept, where it crosses the y-axis. Okay, so what I'm going to do from here is I'm going to go to GeoGebra. You should all be following along with me, okay? And we're going to enter data points. So we're going to enter, okay, starting with your parentheses. Parentheses, 150, comma, 7. Enter. Parentheses, 200, comma, 10. Enter. 400. Oops, if I got my parentheses. Parentheses, 400, comma, 19. Enter. 600, comma, 29. Enter. And 1,000. Oops. Comma, 51. Enter. So there's all my data points. You should have 5 of them. I don't see them on the graph, though. What am I going to do? So, what you're going to do is to view the data points you just plotted, you're going to press on the triple dots all the way on the right-hand side, the 3 dots in the gray. Okay, and it brings you to all these different commands. All right? What I want you to do, I think I made a mistake here. Hold on a second, hold on. What happened here? Hold on. Zoom. Nope, that's not what I want. Hold on, scratch that for a second. Oh, okay, I know now. Sorry, scratch that. We can't see the data points. We want to see the data points. Go all the way up to the top, to the little mechanical symbol, that black mechanical symbol, and press that, okay? You're going to press zoom to fit all the way on the top. and all of a sudden it zooms so that it finds the points for you. So now all of a sudden I zoom out a little bit and I can see all the points, okay, and I go back to my table. Now that I have the points in front of me, okay, we're going to what we call create a list. And also, guys, I'm going to tell you that if you go to Google Classroom and you look it says it says linear regression and correlation coefficient in GeoGebra. This gives you all the directions in this document. Okay, if you open up this document, it will show you a step-by-step direction on how to do all this stuff. Okay, so linear regression, and then you have correlation coefficient at the bottom. We're going through the steps right now. So I'm going to go back to GeoGebra. Okay, we're going to create a list. You're going to go to the 3 dots on the side now, just like I said before in the gray, all the way on the right hand side. And I'm going to type into the search bar. I'm going to type into the search bar, or, oh, sorry, no. Scratch that one more time. Creating a list. I'm going to go to the circle and the triangle on the top. Okay, I'm going to go all the way down to where it says the green list. And then you're going to take your finger and you're going to start in the upper left-hand corner and you're going to press down really hard and you're going to highlight all of the points. Make sure all of the points are covered in the square and let go. Okay, you created a list just now. It's done. Go back to the calculator. There's your list. That green L1 takes all of your points and puts them all together for you. So now it makes it easier for us to do other things. We don't have to type out all the points again. If we didn't have that list, we'd have to keep typing out the points. Okay, so now, okay, we want to find the linear regression equation. Okay, that's what we're doing in our PowerPoint here. We're trying to find the equation for linear regression. So I go back to GeoGebra. I'm going to do a new input. Okay, I'm going to go to the triple dots on the side. And I'm going to type in fit line. Okay, it says fit line now in my bar over here. Okay, I'm going to type in L1 because I'm typing in L1 because that's my list. So I go to ABC, L, and I go back to 1, 2, 3, and I put 1, and I press enter. Okay, there's my equation. There it is, guys, right there. Okay, it doesn't give it to us in y equals mx plus b form, but that's okay. All right, I'm going to go and I'm going to write my equation. 0.74, and it says round to the nearest hundredth. So I'm just going to write it out for now. It says 0.7485. And there's an X on the end of that. Plus, minus 14.5874. Y. Equals 13.4124. Okay, we need to round this to the nearest hundredth. So remember, the nearest hundredth, you have your tenths, your hundredths, your thousandths. And your decimal is here. So the thousandths is the second place over, okay? So we only want to keep 2 places after the decimal. So right now I have to ask myself, am I going to change that last number or am I going to leave it alone? So does 8 round the 4? 5 or above give it a shove? Yes, it does. So we have f of x equals 0.75. I get rid of everything else. I keep the x though. Always keep your variables. Minus Does that 7 round the 8? 5 or above, give it a shove. Yes. So the 8 becomes a 9. And the 4 became a 5. So we have 14.59y, right? We got rid of everything else. Equals, okay, does the 2 round the 1? 5 or above, give it a shove. No. We leave it alone. We get rid of all the rest of the numbers. 13.41. There's my equation, my linear regression equation. That is what they are looking for in the regions, ladies and gentlemen. I'm actually going to get rid of this piece here because you already have y in the equation. Okay. Lastly, and this is actually a little bit easier. Okay, we're finding the correlation. Find the correlation coefficient and state the relationship of the correlation coefficient. So the relationship is what we talked about before, with having a weak positive, weak negative, or strong positive or strong negative. And we're going to round this to the nearest hundredth. So go back to GeoGebra. Okay, this is the easier part. Again, don't erase anything. Leave everything up until you're completely done with the problem. Press the ... In the search bar, you're going to type in correlation. You're going to start typing it in, and it should come up. Correlation coefficient, click on it. Okay? In your box here, your cursor is in between the parentheses of correlation coefficient. Again, you're going to type your list, L1. Go to ABC, L, and then 1. Oh, there it is. 0.9992. So the correlation coefficient equals 0.9992. Rounded to the nearest hundredth. Remember, the hundredth is the second spot. So I'm going to take my numbers here, and I'm going to keep everything that's 2 places after the decimal. I ask myself, does the 9 round 99? 5 or above, give it a shove. Yes, it does. 99 plus 1 equals 100. So really, the correlation coefficient is 1.00. That's great. Okay, if I go back to the chart from the beginning, if we have a correlation coefficient of 0.99 or 1 over here, okay, we have almost a perfect positive correlation. So I'm going to go back to that. So the relationship, ladies and gentlemen, is a perfect, or strong would be fine too. I'm going to say we're strong, positive relationship. Okay, that's all you have to do for that. It's all about knowing how to use the calculator. Okay, so one more problem, and then I'm going to have you guys do your assignment. Okay, so the next one, example 2. It says the table below shows the number of grams of carbohydrates, X, and the number of calories, Y, of 6 different foods. Write the linear regression equation for these data points. Round to the nearest tenth. Okay? Alright, we see linear regression equation. Okay? We go to our GeoGebra. Now, since I'm done with the problem, I can clear everything. And I'm starting over. So you start, again, by putting in your points. 9.5, 138. Ten, 147. 6, 88. 7, 108. And 4, 62. Alright, now I have all my points in there. Remember, I can't see my points. So I go to the top and I go to the little mechanical symbol all the way in the top right hand side. And I click zoom to fit. Now I can see all my points. I'm going to zoom out a little bit. Okay? I'm going to create a list of all my points. So I go to the circle and the triangle up on the top left-hand side, and I scroll down to the green. It says list. I take my finger and I make sure I start in the very top left-hand side, and I highlight. Hey. Make sure all the points are covered. Okay, and then you just let go. It says list L1 is created. So I go back to my calculator and it's there. It's in the green. Okay, so I need to find the linear regression equation. So I go to my input and I go to the three dots, gray dots on the very right hand side. And since I had already used fit line, I'm going to use fit line again. It's right there. It's recently used. So fit line, I type L1. Enter. There's my equation. You write that equation, you got the answer. So I have 11.171 x minus 0.7877 y. You cannot forget your x and your y. Equals, let's get that last number in there, negative 0.5950. Negative 4.5950. Okay, it does say round to the nearest tenth. Nearest tenth, okay, is the first place value after the decimal. So I'm taking everything that's only one place value after the decimal. So here's first place value after the decimal. I ask myself, does the 1 round 1? 5 or above, give it a shove. Nope, it doesn't, so I leave it alone. Minus. Okay, same thing. Here's the nearest 10th place, the first place value after the decimal. Does the 8 round the 7? 5 or above, give it a shove. Yes, 8 is bigger than 5, so I give this a shove to the next one up. 7 plus 1 is 8. So I have 0.8 equals, here's the first place value after the decimal, the 5. Does 9 round the 5? 5 or above, give it a shove. Well, 9 is bigger than 5, so we give this a shove to a 6. There's your equation, ladies and gentlemen, your linear regression equation. Oh, I forgot my y here. And lastly, find the correlation coefficient. Okay, and state the relationship of the correlation coefficient, round to the nearest tenth. So we're looking for the correlation coefficient. Going to GeoGebra, leaving everything where it is. Don't erase anything. Starting a new line. Triple dot in the right hand side, and I go to correlation coefficient. I type L1. Enter. There it is. So 0.9977. Okay, 0.9977. When I round, okay, to the nearest tenth, I'm rounding to the 9 there. Here's the first decimal place after the first place value after the decimal. Does the 9 round the 9? Yes. 5 or above, give it a shove. 9 plus 1 equals 10. So my correlation coefficient is 1.0, or just 1. And if we go back to our chart here, okay, 1 is a very perfect positive correlation, or strong positive correlation. So I'm going to write strong positive correlation. Okay? So, if you look through the rest of the slides, there are 2 more examples, and if you want to go through them yourself, that's fine. You can go through them. I will put up the answers for you. So for example 3, or actually I'm sorry, I would like you to try these on your own. This is not part of the assignment. You don't have to. But if you would like to try them on your own and you're curious about the answer, you can contact me and we can go over it together, or you can email me for the answer. Okay? Since the lesson is over, what you have to do now is you have to go into your Google Classroom, back to our Google Classroom page, and you have to click on Linear Regression A1. That's your assignment. Okay? If it doesn't open, you press on the top right-hand arrow, and it will open up in your Google Drive. Now you can either download this and do it on your iPad with your finger and then save it and hand it in on Google Classroom. You can print it and write in your notes and take a picture of it and upload it to Google, hand it in on Google Classroom. Or you can just do it in your notebook and take a picture of your work in your notebook and hand it in on Google Classroom. Okay? You need to hand something in. Okay, this is one assignment. There's an assignment at the end of every lesson. It's never going to be more than 1 or 2 problems. It's the only way that I know you're viewing the lesson and you actually tried. Okay? I'll go easy on the grading. I don't want you to worry about that. I just want to see that you're trying. Okay? Please don't hesitate to contact me with any questions. I have office hours from 9:30 to 10:30 in the morning, or from 12 to 1 in the afternoon. And you can contact me by email. Some of you have my cell phone number. Whatever works for you. Any time of the day, I'm available. Okay? Thanks, guys, and hopefully I hear from you guys soon.